Okay, welcome to the Blockchain.com podcast. I'm Nick Carey, the co-founder and vice chairman of Blockchain.com, and today I'm joined by Dr. Garrick Heilman, the head of research here. As part of our Crypto Basics mini-series, today we're going to delve into Ethereum. By the end of this episode, we hope that you'll have some of the main use cases for Ethereum, what makes Ethereum a bit different from Bitcoin, and what's ahead for the Ethereum network. So we should probably dive right in and ask the most important question is, what problem does Ethereum solve? So Garrick, I'll let you tackle this one first, and then I can add some color to that too.
Well, thanks, Nick. So Vitalik Buterin, who's the founder of Ethereum, and we'll talk more about him a bit later maybe, was actually involved with Bitcoin early on and really wanted to see Bitcoin support more functionality, in particular smart contracts. And there was a little bit of resistance to that. There's trade-offs with enabling more functionality from a decentralization and security perspective. And so Ethereum was really created to be a smart contract platform. And it's really important, I think, when you talk about Ethereum to introduce this concept of smart contracts early on and explain what they are. Basically, this is software code. It's like an application. So you can think of Ethereum, in some ways as analogous to like an operating system. And on it are these smart contracts, which are like applications like Microsoft Word or Excel. And they automate verification and payment and do a lot of other really nifty things that have enabled things like decentralized finance or DeFi, non-fungible tokens, and also for a whole range of other tokens to actually live and operate on top of Ethereum.
Yeah, I think it's almost impossible to talk about Ethereum without also just sort of referencing some of the principles that it draws from that are from the Bitcoin network. And so when Bitcoin was launched, it was intended to be an electronic peer-to-peer cash system, and it sort of settled on a digital gold use case. And that's okay. These two networks are not necessarily designed to specifically compete with one another. Today, Bitcoin is still sort of the primary store of value in crypto, but there's an active debate now as to whether or not it'll maintain its dominance going into the future. So if we rely on thinking that about Ethereum building on some of the principles set out by Bitcoin, that it's using a programmable blockchain, and it's a little bit more extendable than just being a settlement layer for digital currency. So if the Bitcoin network sort of fulfills the mandate for digital gold, the Ethereum protocol may be best thought of as sort of like a large decentralized digital computer. So both blockchains can be used to store and transfer value, but the Ethereum network is really designed to implement decentralized applications via this concept of smart contracts. So let's talk a little bit more about this. So what is Ethereum? Who created it? Vitalik Buterin was a super early Bitcoin adopter and actually launched one of the first businesses in the world that accepted Bitcoin, which was the Bitcoin magazine. And so a lot of people actually started their journey into crypto following works that were published in that paper or in that magazine. But he went on to kind of hypothesize about sort of a more, I would say, extendable type of network. And in 2015, after crowdfunding the Ethereum protocol with Bitcoin, they launched the mainnet. And today, the Ethereum protocol is the most actively developed blockchain project in the world, with more individual commits to the broader code base from individual contributors than any other project. And I took a quick note of this earlier today. So in their own words from the Ethereum Foundation, Ethereum is for more than just payments. It's best to think of it like a marketplace for financial services, games, and applications that can't steal your data or censor you and can operate basically over a large computer system that's completely decentralized on the internet. So I might turn it over to you, Garrick, to talk a little bit about your understanding of the purpose of smart contracts, and then we can go into some of the use cases of those, because it's a pretty novel idea.
Yes. So for years, I've used a very particular example to explain what a smart contract is that I think has worked okay for most people. It was actually one that one of the Ethereum co-founders, Gavin Wood, described, I think, back in 2014 on stage at a London conference to explain what is a smart contract. So I owe credit to Gavin here on this. But But basically, imagine you own a dog, or maybe you do own a dog, and you have a dog walker. You're a busy person, and you don't have time always to walk your dog, and so you hire a dog walker to come collect Fido, take Fido out for a walk. And imagine you're one of these trust but verify kind of folks who, you think you've got a trustworthy dog walker, but you attach a GPS collar to your dog. And when that dog comes back from the walk with the dog walker, that collar would synchronize with the Ethereum blockchain and a smart contract to verify that the, say, 3 miles that you had agreed would be walked is in fact walked. And then it also automates the payment to the dog walker after making that verification. So it does two things. It verifies that what you agreed, this is the kind of contractual element of the term smart contract, has actually taken place. And then it automates the actual payment. And for years, I've been warning people not to go out and start this particular business. I don't think anyone's actually tried to implement this in any serious way, because most people probably have trustworthy dog walkers. But there's other examples, things like airline insurance, or if your flight's delayed. The idea that a smart contract could check to see if a flight's delayed or canceled, automatically make a payment, or support some of the other more advanced kind of things that have seen a lot of adoption, like automated money market protocols, decentralized exchanges. This concept of automation and trust minimization within decentralized applications that Nick mentioned is really, I think, important to kind of understanding what is possible with Ethereum.
So Ethereum is a global computing platform powered by its own native cryptocurrency called Ether, or ETH. And basically, as the demand for computing power increases because more people are trying applications and building smart contracts, the demand for ETH also goes up. Now, Ethereum is pretty interesting because not only does it propose this sort of programmable blockchain, it also comes with its own programming language, which is called Solidity. So for anyone that's looking to pick up some new computer science skills, definitely recommend looking at Solidity. Solidity developers are now being overly compensated in comparison to other programming languages. And so it's a great way for people that are crypto curious, but also wanting to actually work on the technological side of things to get involved. So a lot of developers are choosing to build applications on Ethereum's blockchain because of its native features, decentralization, censorship resistance, and some of the libraries that have been built up over the last few years. It's the use cases are extensive, but it's important to understand this concept of network fees that happen. So when you want to execute one of these agreements, you need to pay something called gas. So gas is kind of a complicated concept, but if you wanted to drive from point A to point B, you got to fuel up your car. If you want to execute an agreement on the Ethereum protocol, you need to compensate the network for doing so. And they implemented this idea of gas. So gas basically powers smart contracts, it powers stable coins, it powers NFTs, and it powers an entire ecosystem of decentralized financial applications. So I would argue that those are sort of the four main use cases of different feature sets that are being kind of developed on Ethereum today, but it's very, very extensive. So maybe let's talk a little bit about a couple of those. I don't know, Garrick, maybe dig into the use of stable coins, or maybe some of the borrowing and lending protocols built on top of Ethereum.
Yep. So I think stablecoins is a really interesting example of how Ethereum can be used. And it's something that other blockchains support as well, including Bitcoin. There are stablecoins that kind of live on top of the Bitcoin blockchain and live on top of certainly other blockchains. But Ethereum is a major kind of foundational layer for these stablecoins like Tether and USD Coin, which has been growing very rapidly. And a stablecoin, basically, for those who aren't familiar with it, is a cryptocurrency that is somehow pegged or linked to a stability mechanism. Oftentimes it's backed by actual US dollars held somewhere in a bank account. So a token is issued that's linked to those US dollars in a bank account. Some are more complicated and have algorithms or crypto collateral. But these tokens can basically be minted on the Ethereum network and can be supported by Ethereum wallets and exchanges that support Ethereum. So it's a way for new tokens like stablecoins, and there are many others that can kind of leverage the Ethereum network and all the infrastructure and services that have been created around Ethereum. And the value of these stablecoins on Ethereum has just grown massively, into the tens of billions. And it's conceivable even that the value of stablecoins operating on top of Ethereum could one day be greater than the value of Ethereum itself. That's one of the magic things about Ethereum and a blockchain network that can support tokens on top of it like that. Borrowing and lending protocols like Compound and Aave are in many ways like modern money market funds, where you can deposit assets, crypto assets, into these smart contracts using your wallet, and then you could use that as collateral to borrow against that. And you earn maybe some kind of return on making your deposit into the money market protocol, which matches borrowers and lenders in an automated fashion. So it's really incredible in terms of removing the middleman, making finance more permissionless. You don't have to get approved to use these financial services, opening up access globally to ways to access financial services with just an internet connection and computer. That's really, I think, core to what cryptocurrency is about in general, and what decentralized finance and borrowing and lending protocols are aiming to achieve.
So I'm often asked from friends and family members, what's the difference really between Bitcoin and Ethereum? And I think it may be best to summarize it as Bitcoin was sort of built to do one thing really well, which was provide for a way for people to transfer value over the internet on a peer-to-peer system without the use of intermediaries or a central bank. Ethereum really extended that idea quite a bit to build a general purpose programmable blockchain, allowing for many different functions via smart contracts to similarly execute without a centralized, trusted source of truth. So as a result, Ethereum is now really taken on a huge amount of creative potential, in my opinion. We have so many developers and community organizers working to create all those projects you just described. But it also, to put things in perspective, the total market cap today of Bitcoin in early 2022 is roughly $1 trillion. And the Ethereum market cap is about 1/3 of that. So it's done very, very well over the past 7 years, and it's sort of a question mark as to what the future holds. Let's talk a little bit about the difference in the plans. I think going forward, Ethereum currently relies on a proof of work consensus mechanism, and that is planned to be phased out this year in 2022 in favor of a technology called proof of stake. So do you want to talk a little bit maybe about what proof of stake is and its advantages or disadvantages, but also bring in maybe the environmental viewpoint on this issue?
Yes. So yeah, I'm glad we're talking briefly about proof of work and the fact that Bitcoin and Ethereum have both used this way to secure their networks, and the security is foundational to everything about blockchains and crypto assets. Without security, we wouldn't be here talking about this. And proof of work has been reliable for both Bitcoin and Ethereum in making sure the networks at the protocol level have remained secure by creating incentives for miners to deploy computers to basically solve puzzles and earn new tokens and fees as a result. And one of the trade-offs with this approach to securing a blockchain is that it does often to lead to high energy consumption. More and more computers are deployed as the value of ETH and Bitcoin has risen. Those tokens become very, very valuable. More people want to earn those by helping to secure the network, and energy consumption goes up. So one of the potential advantages of an alternative consensus algorithm called proof of stake is to really do away in large part with that energy consumption and not have total computational power be the mechanism for securing the network, but instead rely on token holders themselves to do what's called staking, in essence, post collateral, to then vote on what are valid transactions, in a proof of stake system. And this is something that's not computationally intensive. Could maybe be done on a smartphone without relying on very sophisticated computing hardware. and could see a massive drop in the amount of energy consumed by the Ethereum network should it transition to proof of stake. This has been something that the Ethereum community has been working on for a long time. Many have been frustrated that they haven't made the transition. But the reality is that proof of work has been working, and it's the only consensus algorithm that's really achieved what I would consider to be mainstream adoption with both Bitcoin and Ethereum to date. So it's the most battle tested, but it does have exciting possibilities around reducing the energy footprint for proof of stake networks, and also offering those who are staking their tokens and helping to secure the network a incentive mechanism for doing so.
Thank you. That's a great explanation. So it's expected that by sometime mid-year, the Ethereum community will have a more reliable roadmap for the transition to proof of stake, and that's been something they've been working on for a long time. So one of the challenges I think with crypto is a lot of people are now discovering that sometimes it's not as affordable to move money or transfer value as they were hoping for. So why are fees so high? Like why on crypto, specifically on Bitcoin and Ethereum?
Yeah. So I used the analogy earlier of an operating system, and I don't really always like using that analogy, because another nice way of trying to simplify what is a blockchain, what is Ethereum, is to think of it as a database or like a hard drive in some ways, and there's a finite amount of space, in databases and hard drives on the Ethereum network. And as demand to use that space, to use the Ethereum network goes up, you'll see fees go up. There's a limited supply and rising demand, and that leads to higher prices. And we've seen that, historically with Bitcoin. In 2017, we saw fees really skyrocket on the Bitcoin network, and this last year, we've seen Ethereum fees actually go up even higher than Bitcoins have ever gone up. In part due to just the incredible demand for DeFi, these borrowing and lending protocols like we talked about earlier, decentralized exchanges, and also non-fungible tokens, which we haven't really brought into the conversation yet. But these are, pieces of digital art or music or gaming, digital goods that you earn in a game that have a receipt. That's what the non-fungible token is, that verifies and confirms your ownership of that digital object. And those have really boomed in the last year. And Ethereum has been a major platform for the growth of NFTs. And with that, fees have gone up. And it's really a supply-demand story. There's a finite amount of space, and there's growing demand. And so that leads to fees going up. But there's good news, which is that a number of solutions are coming online, layer 2 networks on Ethereum and other blockchains, to allow more capacity and faster speeds as well for some of these high throughput use cases like NFTs and blockchain-based gaming that are increasingly seeing a lot of great product market fit.
Yeah, one of the things that's interesting about the Ethereum protocol is that it has been upgrading over the past few years at an increasingly impressive clip. So in August of 2021, the Ethereum Improvement Protocol 1559 was deployed, and this actually changed the growth of the ETH supply in a really innovative way. So basically, fees now actually cause the destruction and burning of some of the supply of Ethereum. And so basically, as the network grows, the supply gets constrained on purpose. And so it's possible we could actually see a deflationary cycle with Ethereum at some point this year, but that would obviously be potentially very good for the value of it. So a couple things going on. You've had that EIP that got launched in 2021, the change to proof of stake in 2022. The DeFi market has over $200 billion worth locked into smart contracts now. And then combine that with all the digital collectible marketplaces that are predominantly building on NFTs. It's pretty obvious that the Ethereum network is definitely finding product market fit on a variety of different categories. So what's ahead for Ethereum? Once ETH 2.0 launches, it's likely that the supply of Ether will become deflationary. That is, it will decrease over time. The ETH 2 decrease issuance is predicted to go from 4% annually down to around 0.5. And so if it does that, we should see some pretty interesting pricing changes to Ether itself. So for those out there that are curious a little bit more, how would you go about buying some Ethereum or holding some Ethereum or staking some Ethereum? What do the people need to know?
Right. Well, obviously, blockchain.com is the place you should go to buy your Ethereum and to store it and to use it. There's a number of tokens, ERC20 tokens. This is the token protocol that enables all these stable coins and other tokens that live on top of the Ethereum network. We support on our exchange and in our wallet a number of these ERC20 tokens that you can also purchase and hold and use using your blockchain.com wallet and exchange. We have an Explorer as well. If you want to go look at actual transactions on the Ethereum network, you can do that as well on the blockchain.com. And there's a lot of exciting stuff also in the pipeline. We've already announced that NFTs are coming to the blockchain.com platform. So stay tuned for all the different ways we'll be supporting all the growing ways Ethereum is being used in the months to come here at blockchain.com.
All right. Thank you very much, Garrick. So we hope that was a good sort of introductory 101 to Ethereum, which is today the second largest cryptocurrency by market cap and one of the largest community projects of open source development in the world. So there's a lot of exciting things happening on the Ethereum network and an interesting pathway for progress on the technical side for the rest of the year. So if there's anything else anyone would like to learn, don't hesitate to get in touch with us. We love to create content for you. Thank you very much for joining us today.